Hi, welcome to the lecturelet about modification. And in the previous lecturelet, we saw modification from an intuitive standpoint. And in this one, we'll look at it from a formal standpoint and try to incorporate it into our semantics. So to take a good example, we have the word cat. It's a set of cats, right? But cat in that sense defines a property of things of being a cat. Now we can think of adjectives as providing properties as well. They're perhaps more prototypical in that sense. So something that is gray has the property of being gray. Something that is cat has the property of being a cat. But we can put them together and we get a gray cat. So we want to ask, how does this modification work in our formal semantics? Now intuitively, if something is a gray cat, it's like we've created a new set of things, a set of gray cats. And the set of gray cats are essentially the set of gray things put together with the set of cats. And since that's a very informal way of putting it, we can think about a more formal way. So if we have the set of gray things, we can call it G. And we have the set of cat things, we can call it C. And if you're gray, you're in this set. If you're a cat, you're in this set. And so if you're a gray cat, well, you're in both sets. And remember that we can relate any two sets by finding the set of things that are in both of them. That's called the intersection. And so we can think of gray cat formally as being the intersection of the set of gray things and the set of cats. And in that sense, we get what's called intersective modification. And we can think of it then as taking the set of cats. We don't want all the cats, just the ones that are also gray. Or looking at it another way, we don't want every gray thing. We just want the gray things that are also cats. And remember that, and it might seem weird that it's going both ways, but we want it to go both ways because essentially that's how the truth conditions work. Right? So if we have a sentence, let's say Zoya is a gray cat. S is silent here. Zoya is a gray cat. This is true if Zoya is a cat, and it's true if Zoya is gray. And essentially then what that means is we can get an entailment. That gray cat entails gray, and it entails cat. This would be two kinds of upward entailment, right? Because the intersection of gray and cat is a subset of gray. It's also a subset of cat. So we get the upwards entailment, and we want then intersective modification to reflect that. Now, we have gray cat. And that's going to denote the set of gray cats. So X is a gray cat. And that's going to be the intersection of the set of gray things and the set of cats. But let's think about what kind of function that would look like. We can talk about the intersections of sets, but what we want are the characteristic functions that get us those sets. And there's no such thing as the intersection of functions. That doesn't work. We can put functions together, but not by intersection. That's just a term describing relations between sets. So if we have lambda x in d sub e, if we want to convert gray cat into a function, well, we can do that. X is a gray cat. Right? Or let's think of it this way. Gray cat of x. So the function that gives you 1 if x is a gray cat and 0 otherwise. What kind of function is that? And more importantly, how do we get that function from the function that gets us gray things and the function that gets us cats? So we have the function, the set of gray, the set of cat, and we put them together. How do we put them together? So how do we put these two expressions together to get this one? Now, I say we put them together. How do we know we put them together? Well, that's where the syntax comes in. So for modification, we usually say that it involves adjunction. And in this case, we have gray and cat. And it's going to form a noun phrase. So it joins in the sense that it combines with a phrase marker, creates another phrase marker. So we can build up to here with non-terminal nodes, and then we want to combine these. But when we look at the types, we'll see that we encounter a problem. This is of type ET, this noun. But if you look at gray, it's also of type ET. So if we have two things of type ET, how are we going to combine them? Moreover, what is the type of this noun phrase? We can combine it with the. And we know that the is of type ETE. So this noun phrase should also be of type ET. So, we're in a bit of a quandary. We have two things of type ET. We can't combine them using functional application to get something of type ET. And what do we want here anyways? Well, we want the function that gets you gray cats. And maybe if we look at it using the function notation, if we write out this function more explicitly, maybe we can see exactly how we get that. So we have the function from d sub e to d sub t. We know that because that's what the types tell us. So we've created a semantic object. It's a function. And then we're going to add for all or for any object in d sub e. Function applied to the object equals what? Well, this is a characteristic function, so it's going to map to 1 or 0. 1 based on some conditions. What is that condition? Well, if x is a gray cat. Okay. So we could say that gray cat means this, and that works, but it doesn't really reveal the composition. We have our function. Just to recap, we have our function f from d sub e to d sub t. We know that because of the types. For any object in the domain, function applied to the object equals 1 if and only if, and then we have our meaning, x is a gray cat. But this doesn't really reveal the composition. How did we get from here to here? Well, remember that x is a gray cat if it's in this set. And if it's in this set, then it's in the intersection of these sets. So we can use that fact to start at the smaller sets and get to the intersection. That is to say, x is a gray cat if x is gray and x is a cat. So if x is gray and x is a cat, then x is a gray cat. So now we have x is gray, x is a cat. So how do we turn that into a lambda expression? Well, we can say gray of x, right? Wrong. We can't say that. Remember, what does gray of x mean? It means 1 if x is gray, 0 otherwise. But here, what does this say? It says x is gray. This is 1 if x is gray, this is x is gray. And that difference doesn't seem like a lot, but it means that these aren't the same. So we can't just say gray of x. what we have, though, is what happens when gray of x equals 1, right? If gray of x equals 1, x is gray. So gray of x equals 1, x is gray. Now these are equivalent. We do the same for cat of x. Cat of x equals 1. So now f of x equals 1 if gray of x equals 1 and cat of x equals 1. So what is gray of x? What is cat of x? Well, it's going to be the meaning of these expressions, right? So remember, this is lambda x in d sub e, gray of x. This is lambda x in d sub e, cat of x. So if this equals 1 and this equals 1, then this equals 1. Otherwise, this does not equal 1. Put another way, if you're gray and a cat, you're a gray cat. Otherwise, you're not a gray cat. So in that sense, the meaning of gray cat now fundamentally depends on the meaning of gray and the meaning of cat. And now we can link them together. Okay, if gray of x equals 1 and cat of x equals 1, then gray cat of x equals 1. So far, so good. But the problem now is that we have our meaning, but we don't have a rule of composition that will get us there. We need to compose this. And functional application won't do it because functional application takes something and saturates a function. We're not saturating anything. We need a rule of composition that will not saturate, that will make sure that the type of the output is the same as the types of the sisters. It will have to be recursive, something we haven't mentioned, but something that we recall from syntax is that adjectives are recursive. So if we build gray cat, we should be able to add old for old gray cat and so forth. So it needs to be non-saturating, it needs to have the same mother type as the daughters, and it needs to be recursive. And the fourth condition, it needs to make sure that this entailment works. And as functional application can't do that, but we know that something needs to do it, now we can add a rule of composition. And that rule is called predicate modification. Predicate modification is essentially a generalized form of what we've just done. It states that if alpha is a branching node, whose daughters are beta and gamma, and if both beta and gamma are of type sigma tau, in this case ET, then alpha is the property of things such that this applied to it equals 1 and this applied to it equals 1. And then, in that sense, predicate modification will then take gray and cat and give us gray cat. So we get lambda x in d sub e, gray of x equals 1, and cat of x equals 1. Now, there are other ways of writing this, but we're going to use this one for now. In the literature, for instance, we often leave off the equals 1s, because that's confusing. And then we just accept gray of x as now meaning gray of x equals 1. But we'll get to that. For now, we'll leave it like this. Lambda x in d sub e, gray of x equals 1, and cat of x equals 1. That is what this noun phrase means. We get it from predicate modification, or PM, and it's of type ET. Then we can use the, and we'll get the unique entity in the context that is gray and a cat. But that's how we can formalize intersective modification. And we just introduced it and kind of taken it for granted. But as it turns out, there are a lot of issues in modification that will make us want to wonder if this is the whole story. And we'll talk about those in other lecturelets and in course discussion. But this is a new rule of composition. this predicate modification. And it will be a very useful tool, not only for these kinds of adjectives, but we'll see for many other kinds of expressions that don't involve saturation.